Okay, thanks, I'm muted. Okay, so did you guys get the honor lock? Go ahead, listen, I'm gonna go ahead and unmute you guys for a few minutes just so we get to All right, so sorry, if you guys wanna mute yourself, you're unmuted now. Did everyone have to go through the honor lock and cam scanner documents?
Yeah.
Yes, any questions about how those work? No? Okay. All right, so everybody's good, moving on to section 4.5. I just wanna make sure no one has any other questions. Okay, so what I'm gonna do, I'm gonna go to mute you all again. If you have a question, just type it in the chat window and I'll call on you and you can unmute yourself to ask the question, okay? Does that sound good? Okay. All right, so you guys, if you have any questions, just type question in the question bar, I'll call on you. All right, so section 4.4, we talked about finding the least common denominator. There were 3 different methods. We had the listing multiples, we had the division method, and then we had the factorization method. Remember the division method was the same thing that we did before, where you started with 2, 3, 5, 7, and you had your numbers, let's just say X and Y, and you divided down, and then you were done when you got to 1 and 1. The factorization method is where you listed out the prime factors for both of the denominators, and then you multiplied the ones that occurred, but only as many times. So if you had 2 and 2 in the same one, you listed it twice, if that makes sense. We'll go through some stuff today that'll go through that as an example. And then the listing multiples, let's say you had 6 and 18. You listed multiples 6, 12, 18. Here 18, since they were the same, oh, of course. Since they were the same, you stopped there, and that was your least common denominator. All right, so if you guys have any questions about that, let me know. So today we're going to talk about add or subtract fractions with different denominators. So we're going to use those tools we learned in 4.4 to get a common denominator so that we can then add or subtract fractions. Remember, when we're multiplying fractions, we do not need to have a common denominator because we just multiply across. But when we add or subtract, we can't do it until we have the same denominator. And then we're going to look into comparing and ordering fractions. And again, that's going to have to do with finding a common denominator. All right, so for adding or subtracting, to add or subtract fractions with different denominators, we first rewrite the original fractions as equivalent fractions that have the same denominator. Then we add or subtract the resulting fractions with the same denominator. So here, when we have a different denominator, here's an example with 3/4 plus 1/6. The first thing you need to do is find the LCD. We just did that in 4.4. When we go through these examples, we will walk through how to do it, but here they're just telling us it's 12 because they already know we know how to do it. So here to write the similar fractions with the same denominator, we have 3 times 3 on top, 4 times 3 on the bottom. So that one now is going to be 9/12. That means that 3/4 is an equivalent fraction to 9/12. Here we need to multiply top and bottom by 2 to get that denominator to be 12. So here we have 1 times 2 on the top and 6 times 2 on the bottom to give us 2/12. That means that 1/6 and 2/12 are equivalent fractions. Now that we have the same denominator of 12 right here, we can just add across. So we add 9 plus 2 on the top, but we keep the same denominator. When you're adding and subtracting fractions with the same denominator, you do not add or subtract the denominators. You leave them the same. You only add or subtract the top. All right, why does adding or subtracting fractions with different denominators work this way? Just like we looked at it with the same denominators, we're going to look at it here. So here we have the 3/4 and 1/6. Now, if we were to convert those little pies to the same denominator like we did up here, then we each are going to have 12. So if you were just to redraw this with 12, you can see here we have 9 shaded regions of the 12, and here we have 2 shaded regions of the 12. The area of that shaded region hasn't changed. We're just now looking at it with a different denominator. So if you were to put all those together and add them, you get 11/12. So if you're having a hard time visualizing, I recommend coming back to this diagram. It's a really great way to understand first equivalent fractions, but also how adding fractions works. So the process is to first find the lowest common denominator, rewrite the fractions as equivalent fractions with the lowest common denominators as the denominator, and add or subtract the numerators, keep the common denominator the same. Then simplify your final answer. The main idea here is to make sure the fractions have the same denominator so that they can be added or subtracted. Take the time to find the LCD. Do not find a common denominator just by multiplying the two denominators together. This method does not work well with algebraic fractions that you may study later. That's an important thing. You do need to understand how to find the LCD. Do not simplify any fractions before the final answer. Otherwise, you'll be undoing the right equivalent fraction step. That's very important. So if you write an equivalent fraction to get a lowest common denominator and then you simplify, you're just undoing the work you did. So the idea is to get them to have the same common denominator, add or subtract as you're supposed to, and then simplify as the last step. Many students prefer the vertical format when first adding or subtracting fractions. In example 1, you'll see that. But make sure you also practice the horizontal format. Okay. Make sure you practice the horizontal format. Is generally easier for good sign numbers and for algebraic fractions. So here I'm gonna go ahead and walk you through this example. Normally I don't go through the examples, but I want to just so you guys understand what they mean by horizontal and vertical. So horizontal is when we write it this way. And the reason some people like doing the vertical is because that's kind of how we did it when you first learned subtraction of whole numbers. So here's the horizontal, here's the vertical. So for horizontal, here the LCD of 12 and 8 is 24. Again, when I go through the examples, I will show you how to find those again as a review, but for now we're just gonna take what they say is true. So if we know that it's 24, in order to make 12 24, we have to multiply by 2, which means we have to multiply the bottom and the top by 2. So now this one becomes 10 over 24. So again, 5 twelfths and 10 over 24 are equivalent fractions. Then we have 1/8. In order to make that denominator 24, we have to multiply by 3, which means we have to multiply the bottom and the top by 3 to get 3 over 24. That means that 1/8 and 3/24 are equivalent fractions. And in order to subtract those, you subtract the top, 10 minus 3, keep the denominator the same. And that gives us 7 over 24. And it cannot be simplified. Now that's the horizontal approach. The vertical format, again, here you write them vertically, 5 twelfths minus 1/8. But instead of doing your work down, like I prefer this way, instead of doing it this way, it goes across so that at the end you have your equivalent fractions written like this. So you know it's 10 minus 3 over 24. I personally find this format a little more confusing than this format. But if it works for you in the beginning, that's fine. All right, any questions so far about that? Is anybody paying attention? I can't hear you. So if you're talking, do me a favor, just type in the box because I can't hear you talking. Okay. All right, we'll go on. So here's an example. We have add or subtract as indicated. So I'm gonna write it out and then I'll take a look. So we have 5 over 6 plus 1 over 9. So I'm gonna do it with the horizontal format first. So that means we're just gonna keep working as we are here. So the first thing we need to do is find our lowest common denominator. I'm gonna go ahead and do the division method. I personally find that one to be pretty easy, but the next one I'm gonna walk through the factorization method because that one's pretty tough. So I'm gonna go through the division method on this one. So we have 6 and 9, and we have, remember our prime numbers, 2, 3, 5, 7. So let's start, neither one of these is divisible by 2, so we're gonna move on to 3. They're both divisible by 3. 6 divided by 3 is 2. 9 divided by 3 gives us 3. Oops, you know what? I'm so sorry, guys. 6 is divisible by 2. I don't know what I was thinking. So we're going to start with 2. 2 divided by 6 is 3. 9 is not divisible by 2, so we're going to say 9. All right, so now neither one of them is divisible by 2, so we're done with 2. So we're going to move on to 3. 3 divided by 3 is 1. That means we're done with this side. 9 divided by 3 is 3. We're not done yet. We can still divide by 3, so we say 3. We just carry that 1 down. 3 divided by 3 is 1, so we're done. So that means the least common denominator equals 2 times 3 times 3. And 2 times 3 is 6. 6 times 3 is 18. Okay? So I'm going to leave that there for a few minutes for anyone writing that down. So that means our lowest common denominator is 18. In order to make 6 into 18, I have to multiply by 3, right? Because 18 divided by 6 is 3. So that means that I needed to multiply top and bottom by 3. In order to get 9 to be 18, I have to multiply by 2. So that means I need to multiply the top and the bottom by 2. All right? So that means I have 15 over 18 plus 2 over 18. So now I just add the top, 15 plus 2 over 18. Remember, the bottom does not stay the same. Let me erase this over here so we have a little extra room. All right, so now we have 17 over 18 is our answer. And we cannot simplify that at all. Now, the other thing that's important to note is that, well, never mind. I'll tell you about that when we do the other one, the other method. Okay, so let's go ahead and do this one time with the vertical method. So we're gonna say, what was our fractions? It was 5/6 and 1/9. So we have 5 over 6 plus 1 over 9. So we're gonna say, we already know the equivalent fraction, but since we know our lowest common denominator is 18, we're not gonna go through that. We'll go through the factorization method in the next problem. So we're gonna go through a cross. So we're gonna say 5 times 3 over 6 times 3 plus 1 times 2 over 9 times 2, right? So that's gonna equal 15 over 18 plus 2 over 18, which equals 17 over 18. And there's your answer. So it gets the same way, it's just how you get there. Now, out of curiosity, can you guys type in there and tell me which one you prefer, that vertical or horizontal approach? Are you guys still hearing me? A horizontal? You guys like yeah, me too. So we're gonna kind of mostly stick with that. The vertical approach is kind of, I think it's junky looking, so it's hard to follow. All right, so thank you for letting me know you guys are listening. All right, so let's go through another example. Let's see what's next. So we're on page 57 for anyone following along in their workbook. Add or subtract is indicated. If your answer is an improper fraction, rewrite it as an integer or mixed number. That's an important point because remember, in a couple of the MyLab quizzes, it's very specific. And if you put it, even if it's correct and you leave it as an improper fraction, it'll mark it wrong. So I don't want you guys to get marked down for something stupid like that. So let's go ahead. We're going to do 7 over 20 minus 13 over 30. So we need to find a common denominator. So we're going to use that factorization method. So let's go over on this other page and just find our prime factors for 20 and 30. So 20, we have 2 and 10, that's prime. 2 and 5, those are prime. So we know that 20 equals 2 times 2 times 5, right? That's our prime factor. So let's look at 30. We have 3 and 10. 3 is prime, so we're done there. 2 and 5, both prime, so we're done there. So 30 equals 2 times 3 times 5. So we would say that the lowest common denominator equals, so there's a 2 here, but since it's in both, we're only gonna write it once. And there's a 2 there, so that's done. 3 here, and then there's a 5, but it's in both, so we only write it once. So the lowest common denominator is going to be 2 times 2 times 3 times 5, which gives us, we have 4 times 3 is 12 times 5 is 60. So our lowest common denominator there is 60. So let's go ahead and write that up here just for reference, equals 60. Okay. All right, so 7, in order to make 20 into 60, we have to multiply it by 3. So that means that we need to multiply top and bottom by 3. And then for 30, we need to multiply it by 2. So we need to multiply top and bottom by 2, right? So that means 7 times 3 gives us 21 over 60. And 13 minus 2 gives us, or excuse me, 13 times 2 gives us 26 over 60. So 21 minus 26 is on the top. 60 stays on the bottom. 21 minus 26 equals -5 all over 60. Is that simplified? You guys tell me. Oh, you can't see the screen. Can anybody else? Oh, gosh, guys, I'm sorry. Here's the work real quick. Thank you for telling me. So here, I'm sorry. So we had the lowest common denominators. Here, I'll go back. Do you guys want me to walk through that again? I'm sorry. Jacoya, do you want me to walk? Yeah, I'll walk through that again. Okay, I'm sorry about that. All right, let's start over. So we have 20 and 30. So 20, we have 2 and 10. This is to find our lowest common denominator, remember. So remember the prime factorization, we go through and we stop when they're prime. So our prime factors of 20 are 2 times 2 times 5. And 30, we have 3 times 10 and 2 times 5. And these are all prime. So the prime factors of 30 are 2 times 3 times 5. So then our lowest common denominator, we write it, but if it appears in both, we only write it once. So here we have this 2 here. Even though it's twice there, it's in both, so we only write it once. There's a 2 here, so we write that. That's done. There's a 3 here. We write that. There's a 5 here, but it's in both, so we write it just once. So that means our lowest common denominator is 2 times 2, which is 4, times 3, which is 12, times 5, which is 60. So that's how we got to the lowest common denominator of 60. All right. All right, so then we come over here. In order to make that 20 a 60, we have to multiply top and bottom by 3. In order to make that 30 a 60, we have to multiply top and bottom by 2. 13 times 2 over 30 times 2. So that gives us 21 over 60 minus 26 over 60. Now we just subtract across the top and leave the bottom the same. Do not subtract across the bottom, okay? And that gives us -5 over 60. Is that simplified? You guys tell me if that's simplified or not. Can you use the chat to tell me? Yes, no, not simplified. Very good, Jacoya, thank you. So in order to simplify this, is 60 divisible by 5? Yes, so we're gonna divide top and bottom by 5. -5 divided by 5 is -1, and 60 divided by 5 is 12. So that final answer is -1 over 12. Again, if I had simplified anywhere else in this process, I would have undone my work of getting that the common denominator. Any questions about that problem? Okay, thank you. All right, let's erase that. The good thing about this, even though it's not the most convenient, is that if you need to pause it, you can, because I will be posting the recording, okay? All right, let's go down to this other example. So we're on page 58. Your turn 3. I promise I will show you guys this one the first time. We have 5 over 9 plus -3. All right, so it says add or subtract as indicated. If your answer is an improper fraction, rewrite it as an integer or mixed number. Make sure you simplify your answer at the end, right? All right, so what do I do when I have a whole number? Remember, any whole number is the same thing when you write it in fraction form as writing it over 1. So this is the same thing as saying 5 over 9 plus -3 over 1. Now, when I'm adding a negative, what's that the same thing as? It's the same thing as subtracting, right? All right, so we can also say that this is 5 over 9 minus 3 over 1. You've been trying to get in? Oh, okay. All right, Sylvia, we're picking up with section 4.5. So anything that you missed from this, you can see the recording. So don't worry, you didn't miss too much. We're just talking about the lowest common denominator and how to add or subtract fractions that have different denominators. So you'll get to see the examples, okay? All right, so in this one we had a whole number. When you have a whole number and it's over 1, you know that the lowest common denominator is the other denominator, right? So in order to make this one the same denominator as that one, you need to multiply the top and the bottom by 9, okay? So this is gonna equal, we're gonna come up here, is gonna equal 5 over 9 minus 3 times 9, which is 27 over 9, okay? So then you're gonna keep the same denominator, so you have 5 minus 27 over 9. Remember, you only subtract across the top and you leave the denominator the same. So 5 minus 27 is negative 22 over 9. Am I done? You guys tell me. Okay, what do I need to do? Very good, Jacoy. Yes, we need to convert it to a mixed number. This is an improper fraction, and the directions said to convert it to a mixed number. So let's take that over here. We have negative 22 over 9. How do I start converting that to a mixed number? I'm not sure if anybody's answering. What we need to do is divide, right? So we need to say 22 divided by 9, and we're going to ignore the negative for now, but let's not forget that, okay? So how many times is 22 going to 9? 2 times, right? So we end up 2 times with 18. That gives us 4. So 22 divided by 9 is 2 remainder 4. That means that this equals negative 2 and 4 ninths. All right, and if you need a review of how to do the mixed numbers, let me know, or we can, I can refer you back to the other section, but let me know and we can go through that some more. But remember, you keep the same denominator, your remainder becomes your numerator, and this is your whole number part. All right, any questions about that so far, guys? If you have a question, you can even just type Q in the chat so I know, and I can either unmute you or you can type in your question some more, but it'd be a quick way to let me know if you have a question. All right, I'm gonna move on. All right, add or subtract. We have one more example. Add or subtract as indicated. If your answer is an improper fraction, rewrite it as an integer or a mixed number. Make sure you simplify your final answer. So we have 3, not just 2, we have 3. So we need to figure out how to do this. We have 4, and I will show you the screen in just a second. 4/5 minus 3 over 10 plus 1 over 2. All right. So we need to find the lowest common denominator for all 3 of these. I personally find the division method the easiest way when you have all 3 because it's like a one step. You don't have to go through and find the multiples of all 3. You don't have to go through and find the prime factors of all 3. So I'm going to go through and do this with the division method. So we're going to go, we have 2, 5, and 10. So 2, 5, and 10. Remember, we start with 2, 3, 5, 7. Those are my list of prime numbers starting from smallest to biggest. And then if we need to go on, we go more. since we have some numbers that can be divided by 2, we're going to go ahead with that. 2. 2 divided by 2 is 1. 5 can't be divided by 2, so I'm just going to carry that down. 10 divided by 2 is 5. So we're done with that first column, but we still need to finish up with this. We're done with 2's. 5 can't be divided by 3, but 5 can be divided by 5, obviously. So 1 just carries down. 5 divided by 5 is 1, and 5 divided by 5 is 1. That tells us that we're all done. So since we're done, the lowest common denominator equals 2 times 5, which equals 10. Now, here's another trick. When I look at this, I can see that these both multiply to get that third. So 2 and 5 multiply to get 10. When these two multiply to get this one, we can tell right off the bat that that's going to be our lowest common denominator. But if you can't remember that, it's not the end of the world. You can do this division method and it'll be real quick. And this is another reason why this is quicker than some of the other methods. If we had done it, let's do the factorization method just to show you. If we had done that, we'd say 2, well, 2 is prime, so we don't need to mess with that. So that's 1. Then we'd have 5, well, 5 is also prime. I guess this one's not a good example because it's super easy. 2 and 5, and those are prime. So then we would say 2 equals 2, 5 equals 5, 10 equals 2 times 5. So since we have 2 here, we would say the lowest common denominator equals 2 times 5 because we have 5 in both of those, which equals 10. And see, to me, that division method is just much simpler. All right, so we're going to go back to our problem. So now we know our lowest common denominator equals 10. So in order to make this 4/5 have a denominator of 10, in order to make that 5 a 10, we need to multiply top and bottom by 2. So 4 times 2 over 5 times 2 minus, we don't have to do anything in the middle because it's already over 10. And in order to make this 1/2, the 2 on the bottom 10, we have to multiply top and bottom by 5, right? So now when we multiply, we have 8 over 10 minus 3 over 10 plus 5 over 10. So then we just put it all together. So again, we only add or subtract across the top. So we have 8 minus 3 plus 5 all over 10. All right? So now we have 8 minus 3 gives us 5. 5 plus 5 is 10. So our answer is 10 over 10. Am I done? You guys tell me if I'm done. No? What is 10 over 10? Is that a proper or improper number? Very good, Jacoya. That becomes a 1. 10 over 10 is an improper fraction. So anytime the top and the bottom are the same, that's the same thing as 1. So that equals 1. Any questions about that, guys? Again, if you have a question, just type Q and enter, and then you can ask your question. That way I know to wait for you. All right. Let's do one more quick example, only because I want to make sure you guys know how to handle it when you have that minus and negative. Clear page. Just out of curiosity, how does this stuff look on your end when you guys see the workout on this whiteboard? Is that working for you guys? Can you guys read it and follow it okay? Yes, okay. My handwriting's not the best, I know. So it's harder on here even. All right, so we have 6 over 5 minus negative 2. All right, so what happens when we're subtracting a negative? That's the same thing as adding. So we can go ahead and switch this to 6 over 5 plus, and what do we do with that fraction? We don't leave, or that whole number, we don't leave it as a whole number, we need to make it a fraction. We put it over 1. And what we just learned is that when you have a 1 over here, you know your common denominator is the denominator of the other one. So in order to make this have a denominator of 5, I have to multiply the top and the bottom by 5. So I have 6 over 5 plus 10 over 5, which gives me, well, let's put that down below, equals 16 over 5, right? Because 6 plus 10 gives us 16. That is an improper fraction. So let's convert that to a mixed number. 5 into 16 goes 3 times. We have 1 left over, so this equals 3 remainder 1. Sorry, 1. So we know that this fraction equals 3 1/5. All right? Everybody doing okay with that so far? All right, I will take the silence as a yes. All right, so let's do this. Let's go and clear this. So that covers how to add or subtract fractions with different denominators. Again, I'm going to upload the video of this recording, so hopefully if you guys have any questions, you can go back through it. You can email me, let me know. We're going to talk now how to compare and order fractions. The reason this falls under the same category is because when you want to compare and order fractions, you need to also have a common denominator so that you can just compare their numerators. Now, there's some that are easy. If you have something that's like 1/2, you can say, oh, I know this other one's bigger than 1/2. So I'll show you that too. But the basic idea is that we're going to be converting them to equivalent fractions with the same denominator. All right, to compare two fractions to decide which is larger, we rewrite them with the lowest common denominator as the denominator. Then all we have to do is compare their numerators. Here's an example. We have 1/3, and we don't know if it's less than, greater than, or equal to 5/6. So in order to make the equivalent fractions with the LCD equal to 6, so they're telling us right now that the lowest common denominator is 6. We can also see that because 3 is a multiple of 6. Remember, whenever the one is a multiple of the other one, the bigger one is the lowest common denominator. So in order to make this 3 into a 6, we have to multiply it by 2, which means we multiply top and bottom by 2. To get this fraction, the equivalent fraction is 2/6. Since we can see that 2 is less than 5 in the numerator, we know that 2/6 is less than 5/6, okay? Again, you can also visualize this on the number line, and this is going to help us when we start looking at negative numbers. So here, we see that 2/6 on this number line is definitely smaller than 5/6 on the number line when we're on the positive side. Now, when we look over on the negative side, it's the opposite. Remember that -2 is actually bigger because it's closer to 0 on the negative side of the number line, whereas -5/6 is a smaller number. So remember, it kind of flip-flops when you're looking at negative numbers. All right, the process. Make equivalent fractions with the LCD as the denominator and compare the numerators. The fraction with the larger numerator is the larger fraction. For negatives, place the negative sign in the numerator before making the comparison. That way you know if the negative number is larger than the other negative number, then that's the smaller one. Be careful when comparing negative fractions. Place the negative sign in the numerator before making the comparison. When comparing two negative fractions, some students like to compare as though the fractions were positive and then reverse the direction of the inequality. Okay, so that'll be up to you what makes most sense. Let's go through this example real quick. We have 6/7 and 3/4. This one's not as easy to visualize. I do know which one's bigger right off the bat, but it's not like one is less than a half and one is bigger than a half, and it's easy to go from there. This one we need to make equivalent fractions. So they're telling us that the lowest common denominator is 28. So we just need to make each of them into 28. So that means we have to multiply this by 4/4 and multiply this fraction by 7/7. This new equivalent fraction to 6/7 is 24/28, and the equivalent fraction to 3/4 is 21/28. Since 24 and 21 are both positive and 24 is bigger than 21, that means that this fraction, 24/28, is bigger. However, when you write your answer, you want to write it in the form of your original fractions. We would say 6/7 is larger than 3/4. All right. So let's look down here. We have an example, 1/4 and 1/5. Here's a tip. Whenever the denominator is bigger and the numerator is the same, the bigger denominator means that it's a smaller number. So we already know the answer, but let's figure this out. So how do we find our lowest common denominator? Which method do you guys want to use? You tell me. We have listing multiples, division method, or the factorization method. Somebody vote, anybody vote? Listing, division, any tiebreakers? Paula or Imogen, can you break a tie for us? Let us know which one you would rather do, listing or division. All right, I'll tell you division. All right, we'll start with that and then we'll do listing multiples for the next one, okay, Jacoya? Because I don't think we've gone through that one today, but I do know the division is a little bit more complicated for some people. So let's do 4 and 5. Remember our prime numbers, 2, 3, 5, 7. We're going to start with 2. 4 divided by 2 is 2. We cannot divide 5 by 2, so we keep going. We just bring that one down. There we go. All right, now we keep dividing by 2. Now that we're down to 1 on that column, we don't need to worry about it at all. So 2's done. We can't use 3. Let's look at 5. We carry our 1 down. 5 divided by 5 is 1. That means we're done. So our lowest common denominator equals 2 times 2 times 5, which equals 20. So we need to convert these. So that means we have 1 times 5 and 4 times 5 on the bottom. Kind of. They're not 4.5. Blank. And then we have 1 times 4 and 5 times 4 to make it 20. It means we have 5 over 20 and we have 4 over 20. So which one's bigger? That 5 over 20. So that means that 1/4 is bigger than 1/5. Again, like I said, whenever this denominator is bigger, but you have the same numerator, this one's going to be smaller. Think about it this way. Picture your pie. If I divide my pie into 5 pieces, each piece is going to be smaller. But if I divide it into 4, the pieces are bigger than the 1/5 pieces. Any questions there, guys? Oops. All right, let's go and clear that page. Let's look at -8/12 and -2/3. Since Jacoy asked to do listing multiples, we'll do that one here. So we have 3 and 12. So we have 3, 6, 9, 12. Remember, we just list the multiples of 3. Well, 12 is 12. So we know that we're done. We also can see it because 3 is a multiple of 12. So we don't need to change anything on this side. We can leave this side the same, -8 over 12. And then on this side, we need to multiply by 4 over 4, right? So that means we're gonna get -8 over 12. So these are actually equal. So we would say -8, oops, we can just write it up here, right? Well, no, we'll do this. -8 over 12 is equal to, or gosh darn it, is equal to -2 over 3. So they're equal. Any questions there, guys? Okay. Let's go through this one where we have to actually look at 3 fractions and order them. This one's a little bit more tedious, which is good. I'm sure you guys love that. We have 13 over 21, 2 over 3, and 4 over 7. Let me ask you this. Can anybody, just from looking at this, tell me what the lowest common denominator is? $21. Sylvia, it's not 2 because we have to look at the denominator, the bottom. Did you mean 21 and didn't type the other one, I think? It is 21. The reason for that is these are multiples of 21. So since these are both multiples of 21, we know that 21 is going to be our lowest common denominator. Same thing if we were just looking at like these two. Oops. Since if we were just looking at these two, 3 is a multiple of 21. Or if we were just looking at these two, because it's a multiple. Now, I will show you through the listing multiples method just to show you again how, just in case you forgot. Like, let's say you look at that and it does, oh, don't, please don't be sorry. If you forget that multiple thing is an issue or is a little shortcut, then you could always do your listing multiples method or something like that. So let's look at 3, 7, 21. All right, so we have 3, 6, 9, 12, 15, 18, 21. Well, I know I can stop there. 7, 14, 21, and 20, 21. See, I make mistakes all the time. Oops, goodness gracious. 21. So we have 21, 21, 21. So that tells us that is our lowest common denominator. All right. So let's erase this part. All right. So how do we do this here then? So now let's go ahead and just, what I like to do when I have 3, I take each one and I find the fraction that's equivalent. 13 over 21, we don't need to change because it's already got the lowest common denominator. But let's look at 2/3. In order to make that over 21, we need to multiply top and bottom by 7, right? That's going to give us 14 over 21. Now for 4/7, I need to multiply top and bottom by 3. 4 times 3 and 7 times 3. That's going to give me 12 over 21. Okay. So now how do I order? I have 13, 12, and 14. So that means the way that they go is 12 over 21, 13 over 21, and then 14 over 21, right? Is that my answer though? Can I leave my answer like that and put it into MyLab at the end? No, very good, Sylvia. We need to put it in the terms of our original fractions. So we know our 12 over 21 is the same as 4/7. We know that our 13 over 21 was that was one of the original fractions, so we can leave that. And then we know our 14/21 was the 2/3. That is how we would put it into MyLab. That's the order. Does that make sense to everybody? So don't accidentally put this in. That is wrong in MyLab. You need to make sure you put in the original fractions from the problem. All right. All right, let's go down and do a couple more. Do you guys want to see another one of these with 2, or would you rather see some with another one with 3? Everyone else? All right, let's go through this 3 one, okay? I think that one is a little bit more complicated, and it kind of shows you how to do all the parts. So let's look at this one again. We're on your own, part C. So we have 3/4. Let me write this out and then I'll show you the screen. 5/8 and 2/3. All right. Does anybody have a vote for how we want to do the least common denominator? Do you guys want to see the factorization method again, since it's kind of a pain and it will be on the quiz? Okay. I thought maybe so. So we have 3, 8, and 4. So let's go back. These are our denominator numbers, right? Well, 3 is prime. So we're just going to leave that one as 3. Let's do 8. 8, we have 2 and 4. That's prime, so we're done there. Remember, the idea is you do your prime factorization tree, and we learned that, well, it must be a couple weeks ago now. The idea is you do your factorization tree until you get down to the prime numbers. So here, 2, 2, and 2 are all prime, so we're done. So we have 8 equals 2 times 2 times 2. And the reason we didn't do anything with 3 is because 3 is already a prime number. All right, 4, we do 2 and 2, and those are prime. So if 4 equals 2 times 2, this is a good example because it's got a lot of the same numbers and it's kind of a weird way to do it. So the lowest common denominator, we go through and we find the number for every time it occurs. So but if it occurs in more than one, we only use it one time. Okay, so here we have 2 and 2. So we're only going to write it one time. Let's cross those out. Here we have 2 and 2. Since it's in there, both of them, we're only going to write it one time. Cross that out. Here's another 2, and here's the 3. Okay, I know it's confusing, but how you know which ones to use. The reason is we're trying to find the least common denominator. Now, we can just multiply these all together and get a bigger number, but we're trying to find the least common denominator. And that's how you do it. Because these 2 occur in both, it's like pulling out that factor. Okay, so that's why we can do it like this. So we say 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. So our lowest common denominator is 24. All right, so let's take that back to our other window. We're gonna say lowest common denominator equals 24. So let's look at all of these. So we're gonna have to convert all of these to equivalent fractions with 24, right? So let's look at 3/4 first. To make that a 24, we need to multiply top and bottom by 6, right? So times 6 times 6. So we're gonna get 18 over 24. Then we have 5/8. We need to multiply top and bottom by 3 to get the denominator to be 24. So it's gonna give us 15 over 24. And then the last one is 2/3, and we need to multiply top and bottom by 8 to get that denominator to be 24. So that gives us 16 over 24. So let's put those in order. We have 15 over 24, we have 16 over 24, and we have 18 over 24. Again, I can't believe I wrote 25 as I said 24. Okay, but remember, you cannot put that answer into MyLab. You need to put it in terms of the original fractions. So that 15 over 24 corresponds to 5/8. That 16 over 24 corresponds to 2/3. That 18 over 24 corresponds to 3/4. So that means you would input this order for how to order those fractions from smallest to largest. Any questions about that? Okay, so no one has any questions, is that right? I just want to make sure because that's it for the 4.5. If you want to see another example, let me know right now, okay? And I can go through another example. All right. I'm not seeing any questions. So let me go ahead and give you the practice problems for 4.5. I think I already uploaded them in Canvas, but I'm just going to go ahead and do it again just to be safe. 4.5 problems 7, 11, 25, 27, 35, 47, 53, 57, 69, 73, 75. I've heard from a few people that are really, just on a side note, I've heard from a few people that are struggling with dealing with kids at home or just the stress of everything going on with stores closing and jobs changing. If you have something that you think is going to impact your ability to finish this class or to succeed in this class, please reach out to me as soon as possible. I can escalate it and see what options are out there. I just want to make sure that you guys keep an open line of communication. It is harder now that we're not seeing each other face to face, but I don't want you guys to think that I'm not here to help or that I'm not willing to do whatever I can to help you. I'm going to try to figure out when would be a good time to have office hours. If you want to try to schedule a private Zoom face-to-face to try to go through some stuff, let me know. I'm more than happy to do it. I just need to know in advance so I can work it around with my kids being home. Also, the honor lock and cam scanner, please take a look at that. The exam will be starting next Thursday. We're going to do the exam review on Tuesday. I'll send out a document for that. The exam will start on Tuesday. So like I said last time, what I'm going to let you guys do is do from, I think this is the 2nd through the 6th, there's whatever that Monday is. That way you guys have all weekend. You will have to do it in one sitting. You can't take it, pause it, and come back. But like I said, I'm scrambling, dealing with having the kids at home, and just work has totally changed for me. So I know that everyone's got a lot going on. So I did want to give you guys a little extra time to figure out if you needed to take the exam at a different time. So please take a look at the honor lock stuff. Take a look at the cam scanner. If you have any problems opening those documents, email me as soon as possible so I can make sure everybody has access to it. And if you have any questions about any problems or anything going on, please let me know. If you're having problems with internet access or computer access, let me know and I'll escalate it and see what options are available. Also, I posted an announcement this morning about tutoring. They are still doing tutoring sessions. I think they're trying to figure out how to do private scheduled tutoring sessions through the tutoring center. So if you do need it, go to the announcements. There's a post in there with an email. Jasmine Carter is who you need to contact for tutoring. So if you need that, let her know as soon as possible. So if no one else has any questions, that's going to be it for today. But if you have a question, let me know. All right. Anybody else have a question? If you do, let me know. Just write Q and I'll unmute everybody, or I can unmute you. Okay. Because if you want to talk, I can let you talk. All right. All right, guys. Thank you so much for coming. I appreciate it. Have a good weekend and I will talk to you guys soon. All right. Have a good weekend.